In this video, we solve an integral problem using long division and partial fraction decomposition. We want to integrate 6x x to the 6 minus x cubed plus 1 divided by x to the 4th plus 9x squared dx. Long divisions of x to the 6 minus x cubed plus 1 divided by x to the 4th plus 9x squared is as follows. So we write to the denominator to the left or on the left hand side, and the numerator is in there, replacing missing term with 0 raised times x raised to the required exponent. So exponent 5 is not there, so x0, x to the 4th, and so on. So now how do we do it? Take x to the 6, divide it by x to the 4th, you get x squared. Multiply everybody here by x squared, you get x to the 6 plus 9x to the 4th. And then flip all the sign and simplify. Then you get negative 9x to the 4 minus x cubed, and then bring the remaining terms down. So now divide, you see check the exponent is 4, and the exponent there is 4, so we should continue with the division. Negative 9x to the 4 divided by x to the 4 is negative 9. Now multiply by negative, this side by negative 9, you get negative 9x to the 4th minus 81x squared. So flip the sign again and get 0x to the 4th. Now bring down the x cubed, and you have plus 81x squared plus 1. So the degree here is 3 and the degree there is 4, so we stop the division. And this leads us to the given integrand is x squared minus 9 plus negative x cubed, which is the remainder here. That means the quotient, which is x squared minus 9 plus remainder, which is negative x cubed plus 81x squared plus 1, divided by the denominator that we had at the beginning, which is x to the 4 plus 9x squared. This leads us to the following. We factor the denominator. The common factor is x squared, so we factor out x squared to get x squared factor to x squared plus 9. See that? Realize that x squared plus 9 is no longer factorable. You can no longer factor it. So then the partial fraction decomposition of this expression is, because we have x squared, we need two terms in x. So one a over x, the other one b over x squared. And plus, there is only one term with denominator x squared plus 9. That is, we have cx over plus d over x squared plus 9. So it's time to determine what a, b, c, and d are. So that reduce this right-hand side in to one denominator, to a common denominator. The least common denominator is x squared factor to x squared plus 9, which is what we have on the left-hand side as well. Once doing that, that means we get ax factor to x squared plus 9 plus b factor to x squared plus 9 plus cx plus d factor to x squared. And now distributing ax here, we get a x cubed, so a times x cubed, and then we get ax times 9, which is 9ax. Then here we get bx squared plus 9b, bx squared plus 9b, and we get cx cubed plus dx squared, cx cubed plus dx squared. And so everybody here, every term has been taken into account. So we factor, we simplify, we get this numerator. Now it's time to do the matching. So they match the coefficient of like terms. So you have a plus cx cubed, and you have negative 1 times x cubed. So a plus c is negative 1. We do the same for the term in x squared, for the term in x, and for the constant term. That leads us to this. A plus c is negative 1. B plus d is 81. And 9a is 0 because there's no the term in x is not existent here, meaning that its coefficient is 0. And 9b has to be 1. So b is 1 over 9, a is 0. So solving for c, we get c is negative 1 minus a, which is 0. That means negative 1 is for c. And d is 81 minus b. That means 81 minus 1 over 9. So, and solving, we do get the following. C is -1, D is 728 over 9. So we can now rewrite the expression, the integrand as x squared minus 9 plus 1 over 9 x squared minus x over x squared plus 9. See that I split it into two. Why? Because I know, you see, if you take the derivative of x squared plus 9, you get 2x, which means I can just multiply this by 2 and multiply the front by 1/2, and I have my integral. And then I know the integral of 1 over x squared plus 9, so that's why I split it. Therefore, I ask you to check that this is correct. In fact, if you check that this is correct, then checking that this one is correct is not difficult. And actually, I did check it, which is good. Now, the given integral integral becomes integral of x squared plus 9 plus 1 over 9 integral of 1 over x squared minus 1/2 times 2x minus 1/2 times integral of 2x over x squared plus 9. Why did I write that? I just explained, because we take the derivative of x squared plus 9, we get 2x. So now I create 2x. I multiply by 2 and divide by 2. That means you just multiply by 1. And then I move this to the front of the integral, and then you get integral of 728 over 9 integral of 1 over x squared plus 9. Now each of the integral now becomes easy. So that is 1/3 of x cubed plus 9x minus the integral. If you take the derivative of 1 over x, it should give you negative 1 over x squared. So that means the integral of 1 over x squared is negative 1 over x. So 1 over 9 times 1 over x is 1 over 9x. So then minus 1/2 the integral of this. Do change of variable, set u equals x squared plus 9. The derivative of du will be 2x dx. So 2x dx is du. We have 1 over u du, which is ln of u, and u is, we said, x squared plus 9. So that's how we get this term. And for this one, we learned that the integral of 1 over x squared plus a squared is 1 over a arctangent of x over a. So in this case, a is 3. So now we have 728 over 9 times 1 over 3. That means 1 over 27 in total times this, in tangent inverse of x over 3 plus constant.